Hi everyone, thanks a lot for joining. So my name is Norbert, I'm doing protocol research at Gevolut, and today I'd like to talk about the network design of our decentralized proving layer. Let's kick it off. So initially I'd like to talk a little bit about why decentralizing proving is important. So we started off developing off of the problem, meaning proving markets are susceptible to centralization, and we don't want to replicate something that has been already seen in Web 2 regarding compute networks. So because of that, we feel that centralization is important. That's something that we should start building off of, and with that in mind from day one. And we'll talk a little bit about that. So some design considerations that ZK or validity rollups or even ZK-L1s may have. Like a very important thing is whether to enshrine or not to enshrine their proving networks. So in essence, that would mean kind of like a decision between external dependency, whether they want to take that on, or versus hardware efficiency. And I'll talk a little bit about this. So in case a protocol decides to build an in-protocol prover network, it would mean that there will be no external dependency. However, the question is, can it provide high enough hardware utilization and profit potential for prover nodes, node operators? While if they go with an out-of-protocol solution, then what is the cost of compute efficiency? That's a good question. Is this cost decentralization? Because we've seen that in quite a few times. Regarding third-party proving services, we could say one of the key questions when designing such a proving service would be how to distribute workloads. And this could happen through competitive auctions. This could happen through proof racing, which is kind of like the fastest, everyone racing to generate the proof, but the fastest one getting rewarded only. Or would it be randomness or some combination of these? Actually, regardless of the final decision, we need to be aware that some of these mechanisms are very prone to centralization. For example, auctions and underbidding within auctions is actually happening nowadays too. So let's say any super powerful entity who could afford generating proofs at loss and constantly underbid everyone for years could actually realistically reach monopoly in an auction setup, for example, or the same entity, very powerful, could be dominant in a POW type of proof race environment as well. We just need to be aware of the trade-offs and design accordingly. And from our perspective, talking about Gevolut, for us, making decentralization-focused design decisions is key, because this is what ensures that no one can control where proving happens. This is how we can afford and how we can offer high liveness guarantees, high censorship resistance, trustlessness as well, and of course, fair distribution of rewards and workloads. So this is a key again. And all this boils down to being a credibly neutral network that offers real decentralization. And the good thing is that the future is bright in a sense that, for example, my personal view on this is that with Gevolut, and on the one hand, I'm a little bit biased. On the other hand, last year I did extensive research with 2 other Ethereum protocol fellows on prover mechanisms. And honestly, the thing is, I was convinced in-protocol networks would be the way to go for ZK rollups to decentralize their prover networks, for example, until I met Gevolut. And we started going into details about the actual design and then started working out the details. And there exists a solution that can legitimately substitute any validity rollup being or making their own or building their own prover network with offering the same liveness guarantees, censorship guarantees, decentralization guarantees that they would get were they to build their own network. Not sure if I was able to express it properly, but the thing is, we're building something cool with Gevolut. So let's go into the details. It's a full-stack ZK cloud offering, actually, that we are building. It's a decentralized compute network that is exclusively optimized for proving and verification. We do proving, we do verification, and we offer high level of customization. This includes plugging in TEEs, specialized hardware like FPGAs and ASICs. Through this customization, you can actually manage data availability or be in touch with data storage solutions and other things as well. It seems I don't have too much time, so I need to speed up a little bit. We're going to be cheap, aggregating workloads from all over the industry, and by cheap I mean that orders of magnitude cheaper than what proving currently costs out there. Performant because our network is exclusively optimized for proving and verification. The network itself, the underlying blockchain, the L1 that we are building, is super lightweight. We don't host any any smart contract state. We have basically no re-execution. So the only thing we focus on is prover and verifier programs and how they can easily be deployed on Gevolut and how we can offer cheap and performant proving. And we are also flexible because basically most of the proof systems out there can be deployed with minimal modification. We support different languages. Our environment supports multi-threading, GPU proving, etc. So I need to speed up a bit. Our programs come in two flavors, prover programs and verifier programs. Imagine these as like on-chain programs. It's a metaphor, but the same way you deploy a smart contract on Ethereum, you can deploy prover and verifier programs on Gevolut. We have two main network actors, validators and provers. The validators are processing the proof requests, broadcasting workloads to provers. They reach consensus on block content and replicated state. We randomly select a leader for every block. They are responsible for ordering the transactions and proofs into blocks. And there are normal, usual rewards around validation. However, for provers, obviously, the main task of provers is proof generation. We randomly select one prover initially to generate the proof. Verification is done by a subset of provers, again, randomly selected. And obviously, they cannot be selected for verifying their own proofs that they've generated. The participation is staking-based. There is capacity verification initially, and we also do periodic random verification to make sure that anyone in our active prover set is actually capable and available for generating proofs. Provers need to accept or decline a workload, which means that in case they don't do it, another round of random selection runs and we'll reallocate the workload right away without the fallback mechanism triggering. But there is also a fallback mechanism in case the prover declines a workload, or in case the prover accepts it but does not deliver the proof. Decline is an interesting thing. We don't want to, just one note here, we don't want to punish provers who have some ad hoc constraint at their end. So we allow a couple of declines per month, but it's limited so that the feature is not spoiled. And users can actually also request additional redundancy by submitting other multiple workloads as well if they don't want to run the risk of or don't want to wait the time of a fallback mechanism getting the proofs for them. Yeah, I think I'll jump this one here. Yeah, maybe a little bit about economics. So two components for proving fees. A small transaction fee to prevent spam, and it's based on compute fee. We are calculating the actual proving fee based on the resource requirements needed for the proof request and also the compute time, the maximum compute time up to which the prover program should run. And then the user will know initially and in advance how much the fee is going to be. The user, however, is like we do a rebate of user fees in case the proving takes longer. So yeah, let me put it in a different way. The prover reward is declining by the elapsed time it takes for the prover to generate the proof. So it means that all provers are incentivized to generate the proofs ASAP, but in case there is some delay in proof generation, the difference that will be deducted from the prover reward will actually be rebated to the user. So they are in a way compensated for that. We've got custom prover sets built on top of the global prover set. I think I already mentioned a couple of use cases, like plugging in specialized hardware, ensuring interoperability with other blockchain platforms, data management solutions, etc., or managing external software dependencies. The participation here will be opt-in from the provers, and yeah, you can read here about some technical aspects like communication, for example, which is super important if we have an external dependency. That is going to be done between the external program and the prover program via a virtual isolated network. Within the Gevolut node, there is flexibility in configuration. And proof pricing, yeah, another important thing, it's going to be determined in this case by the deployer of the prover program, the custom prover program, and there is going to be network subsidy applied proportional to the percentage of the global prover set participating in the custom prover set. In a more digestible way, basically, the more provers from the active set participate in the custom proving, the higher the network subsidy for prover rewards. We have a DevNet up and running. It includes the full proof generation pipeline. You can deploy any arbitrary proof system as a prover program. You can have proofs generated. You can have them verified. It's currently all free of charge because a certain selected chunk of node operators are running these nodes currently. So feel free to benchmark any proof system you have or prepare as many proofs as you want. And we are happy and very glad if you can give us some feedback, good or bad, regarding what we should improve in the DevNet. You just need to register a key, generate a key and register a key, and off you go. So yeah, just the last thing, we generated around almost 900K proofs in the past 8 weeks. The DevNet is steady. Feel free to use it, and yeah, as much as you want. Thank you very much for having me. I guess, yeah, I'll just put the roadmap here, and happy to answer any questions you may have outside the talk. It seems that I think I'm over time already.
It's fine.
Thank you very much for having me.
Thank you.